Welcome back. We are going to look at functions in C++ today. So starting off, we're going to make a few functions of our own. We're also going to do some exercises where we take some functions that other people have written and use those to get some tasks done. Starting off by writing a program that contains a function called hello worlds. It has a parameter that is a value given to that function. Think about, like, in mathematics, you often hear f of x very often. X is what we would call a parameter for your function f, and it takes that value and does something with it. Now in math, if you have something like, f of x equals x squared, the way we would think about this in computer science is saying, okay, we have a function called f, a parameter, which is usually, could be an integer, could be a floating point, called x. And it returns, that is, it gives back the value of x squared, so returns x times x. Now, in this problem, we want our function to be called hello worlds. It's going to take a parameter that's my integer, and it's going to print hello world my integer times. Now, notably, it doesn't say here that hello worlds needs to return anything, so it's not the case that we're going to use this function to output some kind of value. Instead, it's just going to do something for us. So let's start writing this function. And importantly, I'm going to grab what's here so I don't have to refer to this again. Okay. So let's write our function. Now, main is our function in C++ that all of our code begins from. So later when we finish our function, we want to use it. This is where we're actually going to call it, where we're going to reference it, give it a parameter, and do something. But before main is where we want to actually declare this function. That is, we want to define what it is, and then we want to declare what it is and define it. So declare means specifically we could just say something like void hello worlds, and it has a parameter my integer, and you would just do this. I think this should compile actually. Yeah, everything is fine. So what I've done here is I've declared the function, which is basically saying to C++, hey, later down the line, I'm going to write a function. It's called hello worlds, and it takes a parameter my integer. I'll tell you later what it does, but for now, this is a function that will exist, and that way I can choose later on where I want to write my function. Maybe it's the case that this is actually in another file or somewhere, but to keep things easy, we're actually just going to define it, say what it does right below. Now, what is this void here? Where did this come from? Any function you write in C++, in many other languages as well, needs to specify what kind of value is going to come out of it. So if, for instance, my hello world was just going to give you back a number, say it was going to return 0, I would need to specify that hello worlds is a function that returns an integer value. But as I mentioned before, hello worlds isn't supposed to return anything. So we're just going to call it void hello worlds, meaning that there is no return statement, and it's just going to do stuff. And in this case, what it's supposed to do is print hello world my integer times. So I'm going to print hello world, and the amount of times that I want to do it is my integer. Now, we know from our last exercises how to do a loop, so how to get something to run multiple times. Since I don't know the value of my integer, I'm going to use that as part of my loop to repeatedly print hello world. So again, since I know a count of how many times this loop is going to run, I can say for my counter variable starts at 0, it goes up to my integer, and my I goes up by 1 every time. And what's going to go in this loop is just printing hello world. There we go. For a good code style, you may want to add some comments in here just to specify things like, for instance, this function prints hello world my integer times, something like that. In general, it's always good to specify what a function does so that anybody who is trying to use your function, in the case that you, 2 weeks down the line, or somebody else, sees this function and wonders, what does this actually do? How does it work? It's always good to have some kind of documentation for that. For now, this is going to be temporarily optional, but later in the course, we're going to tell you some rules for how to do this, and at that point, you will have to write comments in. But for now, prints hello world by integer times. There it is. Now, we need to actually use this function. Right now, our main function just does nothing. We want to actually call hello world, and let's say we want to print it, I don't know, 10 times. To do so, since we don't need to use, since this isn't returning anything, we don't care about the value, we can just call hello worlds. We need parentheses to specify any parameters that we're going to pass to it, and we're going to do it, 10 times for fun. And there's hello world. It's stretched across because I forgot to add in a new line character. Let's put it in like that. There we go. 10 hello worlds printed straight down. And this is our first function. Not too complicated, hopefully, but the main things to keep in mind here are, first off, you need to define the function. The declaration is somewhat optional. I believe if I comment this out, this should still work okay. However, there will be cases where you need to declare it first in the event that the function maybe is written somewhere else in your code. It's also good formatting just so that you can make it clear to anybody who's looking at this file, and suppose this function was like, 200 lines long or something. Rather than trying to find out where this function is, you can usually just go to the top of a file and see, oh, here are the functions that have been declared here. And in our main function is where you actually need to call it, where you actually need to decide, okay, what is the parameter, what are the parameters that I'm going to pass to this function, and in what order do I want them to run. For now, we're just doing it once, but later on you might need to combine a bunch of these functions and do lots of different things. So that's our first exercise. Let's move on to the next one. Okay, so using the CMath library. So before anything else, before I even continue reading, I know I need the CMath library, so let's go get it. So I always have this library because I need this one to output stuff, and I'm going to add in CMath because it said I needed it. So there we go. We got our CMath library. I'm going to delete all, or for now I'll just leave this stuff here. These functions are fine to leave here because as long as I'm not actually calling them in my main function, they can just hang out. It's fine. Write a program that shows whether or not the square root function behaves differently with integers and floats. All right, well, let's try it out. We got some more stuff to do later, but let's do one thing at a time. Square root function. So since we've imported CMath, we now have a square root function. If I didn't import CMath, I think that C++ would complain at me and say, what is this square root thing? So suppose, for example, I wanted to output the square root of 4, for example. And let's suppose for a second I didn't have CMath. I think this should give me an error, if I'm not mistaken. Yeah. So this is good to know common error message. SQRT was not declared in this scope, and it points at this little function and says, hey, here's a problem. And what this means is that by scope, we're referring to the part of the code that we're working with right now. This function was not declared, so no one has specified something like, int square root of some value. Now, I don't need to actually set this up because the CMath library I was supposed to include already has this declaration and a definition for it. The code for the square root function, I don't need to come up with it. I guess I could, but that sounds like a lot of work. Why do that when someone else has written the function for me? I can just take it. And now, when I try to output the square root of 4, it gives me 2, which is the square root of 4. Now, the question asks us to determine, is there a difference between the square root function running on integers and the square root function running on floating point numbers? So let's find out. When we're thinking about test cases, trying to figure out if code is going to work or not, something you should be very careful avoiding doing is using examples that are very basic and simple. And what I mean by that is square root of 4 is 2. There's not really a lot of complexity here. I imagine if I were to print the square root of 4 and I was to compute the square root of 4.0, they're probably going to be the same thing. Wouldn't be surprised. They're both 2. But this doesn't really mean much to us, mostly because since the square root of 4 is just an integer too, it doesn't actually tell us anything about, does the square root function have the ability to give us floating point numbers? We can't see that from this simple example. So what we would rather do is use some examples that might cause interesting behavior, things to happen a little differently, and then we can compare and see, okay, is this actually doing what we think? So let's suppose we take the square root of 7. I don't even know what that is. and the square root of 7.0. And now, is this going to give us two different values? Is it going to take the square root of 7 and round down, or is it going to take the square root of 7 and leave it as is? Well, let's find out. All right, look at that. The square root function has given us two floating point numbers this time, and that's because it treats floating point values and integers the exact same way. Now, I'll talk in a couple of examples about how exactly it's able to do this, because clearly 7 and 7.0 are two different types of values. But in your parameters, you can usually only specify one type that you're going to use. I can't do something like, int or float my integer, right? Like, this doesn't actually work, and this will, cause C++ to get very confused. Because anytime that you're defining a function, you can only give each variable one type. But we'll see in a little bit exactly how you get around that. But anyway, the thing we were trying to figure out is, do they behave differently? And it looks like they are. Square root function works the exact same. Now, figure out what the pow base exp function does that make a loop to do the same thing. Well, we can probably speculate as to what this function might do, but just to sanity check, let's find out. So if our expectation is exp is short for exponent, and then pow base exponent is probably going to take the base and raise it to this exponent. So to double check, let's write an example. So we know that the square root does the same thing. Let's make a new little output statement. Okay, and now, again, going back to verifying what stuff does. If I write pow 2 of 2, I expect this should give me 4. It does. But here's the thing. What does that tell us about pow? Really nothing, right? Perhaps pow is a function that adds two numbers together. 2 plus 2 is 4. What if it multiplies two numbers together? 2 times 2 is 4. It could also be the exponent. 2 squared is 4. So we learned basically nothing by doing this example. So we want something where clearly the values that we have here are only going to give us a specific value. So let's try instead 2 and 5. Now, if this was addition, we would get 7. If it was multiplication, we would get 10. We think it's exponents. So 2 to the 5 should give us 32. Let's find out. And look at that, 32. So our theory is correct. Now, we have to write a loop to do the same thing. This is a very short piece of code, very elegant, because, we just write this little bit, and it gives us our 2 to the power of 5. To write a loop, we have to do something a little messier. So let's suppose we wanted to calculate, 2 to the 5. We're going to have our base is 2. We're going to run a loop that's going to have to go 5 times. I is 0. I is less than 5. I plus plus. And we're going to need to calculate our answer, which is going to start out as 1. And so the reason for this, notably, is that let's suppose we wanted to calculate 2 to the 0. What is 2 to the 0? It's not 2 times 2, 0 times. It is just 1. So we want to make sure that whatever value we put for our exponent, that it's able to calculate 2 to the 0 correctly, 2 to the 1 correctly, 2 to the, and so on. So every time that we run this loop, what happens when you calculate an exponent, it's you're multiplying by the base again and again and again. So you can think of any exponent as 1 time, like say we're doing the powers of 2. It's 1 times 2 times 2 times 2, however many times you want. So in this case, we want answer. You can do answer equals answer times base, or we could do answer times equals base. They're the same thing. Answer times equals base. It's 2 lines of code, mean the same thing, just a different way of writing it. And let's compute our loop. So let's output our answer. Okay, what mistake did I make? This should be a semicolon. And how did I know that? Expected a semicolon before the parentheses. That means somewhere in here I was missing a semicolon, and the first place I noticed I was missing it is right here. Simple mistake, very common thing, but it's good to realize what this mistake is so that you don't spend hours and hours trying to figure out where did that semicolon go, right? Okay. There. Let's try that again. You having some trouble here? The compiler might have some issue. You know what? Let's just take our code, reload the website. We got some internet issues clearly. Oh, there we go. Okay, yeah, 32, 32. So our loop and our exponent thing here are doing the same thing. Let's, again, it's always good to double check these kinds of things. Let's suppose we do want to calculate 2 to the 0. It's kind of a weird situation, but let's give it a shot. So this loop should run 0 times because I starts as 0 and is never less than 0. So our answer should just be 1. Which is the same thing we get from our power. Now, you could go, beyond and try to calculate the negative powers. I wouldn't be surprised if this actually works correctly for negative powers, and we can try it just for fun. So 2 to the power of negative 3 is, what's that, like 1 over 8.125? Obviously, our thing is not going to work, our loop is not going to work for negative powers, but just out of curiosity, let's see if the power function can behave correctly for that. Yep, there we go, 1/8. So very convenient in that anytime we're working with positive powers, sure, our loop will probably be okay, but this power function clearly has more behavior than we were able to do with our simple loop. It works for negative numbers, for 0, for positive numbers. So rather than writing all of this code, we can just simplify things down to calling the function that someone else has written. Okay, so that's our little exercise there, and we'll move on to the next one. Okay. Using the CTime library. So again, we're just going to immediately grab that CTime library. So we're going to need it. CTime. We're not going to need this code. Comment it out. Okay, write a program that prompts the user for a number and then does stuff. So first things first, let's prompt them for a number. We need my number. Please enter a number. We get that number. Okay, done the first part. Don't have to worry about that anymore. Prompt them for a number. Generate and print that many random numbers between 1,000 and 2,000. All right. I will need to use some functions here to initialize randomness as a parameter for that and to generate random numbers. But we notice immediately that that many random numbers means there's something that I'm going to do repeatedly. So again, indicates that I'm going to need to make a loop. So that many refers to the number that the user gave me. So let's make a loop that runs that many times. So I need a loop. I is 0. The number of times the loop is going to run is the number that they gave me, so I is going to be less than that number. And I goes up. Okay, so that many times I need to do a thing, which is generate and print random numbers. So I'm going to need to make a random number. We'll figure out in a bit how to make the random number, and I want to print it. Random number. Okay, so now I got to figure out how to make these random numbers. Now, this is where, things might not be immediately apparent if you haven't used some of these functions before, so this is where we kind of got to figure out, okay, what do all these things do? So, srand is a random initializer, and what that means is that anytime that your code runs, if you don't figure out a way that you can tell the computer how to start generating random numbers, it's actually always going to generate the same random numbers every time, because it's not really random. In reality, a computer can't simulate real randomness. There's just no way to really do that. So if I were to, for instance, use my random number generator function over here, and this is a random number generator function, rand. Let's actually just take a look at what that looks like. Suppose I don't do any of this initialization stuff. I just say, you know what, this rand function gives you a random number. Let's use it. Okay, int random number equals rand. Let's just see what happens. Give me 5 random numbers. Okay, well, let's see what happened. It gave me, well, first off, these numbers were huge. So clearly I'm going to need to figure out how to simplify these down a bit into a smaller range. But Okay, 1804289,383. Now, if I run my code again, 1804289,383. Maybe I got unlucky. Maybe it just happened to do this same number another time. Let's try again just to see. Are these numbers really random? Because it seems to be giving me the exact same numbers every time. And this is exactly why you need to initialize randomness with what's called a seed. In other words, a starting point for growing your random numbers. Rand here is what we call a pseudo-random number generator. It makes random numbers, quote unquote, but in order to figure out how to make new random numbers, it needs to have a starting point. And you generally want to have that starting point be something that is constantly changing. In other words, you don't want to be able to make the same set of random numbers over and over. So you have to think about, okay, when I run this code, what's something that has changed from the last time that I ran it? And there's probably more likely than not only one thing that really has changed since you ran it the previous time, which is time. So before we generate our random numbers, we're going to use time to set up our random number generator. So srand here is to seed our random numbers, to figure out how to get them started, and to seed them correctly, we need a parameter for this. Now, again, I could put in a different number. Let's suppose I just put in 5 for fun. I'll get a new set of random numbers here. I won't get 1804, whatever. See, I'm getting new random numbers now. But again, if I run this a second time, 59001. 59001. So putting just a number in here, not really serving a good purpose. What's some number that is going to change over time? Well, it's going to be the current time. And time with parentheses of null is just a way to tell C++, hey, give me what time it is. Because what time it is has changed. And it's not exactly random how much time has changed, but it is something that is different and has varied since the last time we ran things. So now every time I run this random number generator, let's see, 51384. Let's try it again. A different number. And now every time I run this, the random numbers that I'm getting are going to be completely different. So they actually have some sense of randomness to them. Okay, now there's one last thing I haven't done yet, which is they have to be between 1,000 and 2,000. Clearly what I have here are gigantic numbers which are not within that range. So I need to be able to take one of these random numbers and shrink it down into the range of 1,000 to 2,000. So the first thing that comes to mind is that the number, the amount of potential values I have, there's 1,000 different values, right? I can have 1,000, 1,001, 1,002, so on. I guess you could say 1,001 different values if you count 1,000 and 2,000. What really matters here is that there's 1,000 different values, and the lowest number I can start with is 1,000. So what I want to do here is take this and first off figure out how to get from this to one of 1,000 possible different values. Well, we actually learned a function already which will give you 1,000 different possibilities, which is modulo. If I take this, modulo 1,000, let's make 20 just for fun. Notice that now all of my values are numbers that range from 0 to 1,000. So that's good, but it's not quite what we wanted, right? We wanted numbers from 1,000 to 2,000. And we have currently 0 to 1,000. So how do we shift 0 to 1,000 to 1,000 to 2,000? Well, let me just add 1,000. So I take this and I add 1,000. Look at that. They're all numbers within the range of 1,000 to 2,000. So anytime that you're using your random number generator in C++ specifically, other random number generators in, for instance, Python may behave a little differently, but C++ random number generator makes these really big numbers which you can then condense into something that you're actually looking for using the modulus operator to figure out your range that you're working with, and using addition to increase the base to what you need it to be. So first thing, anytime you're trying to think of a range, figure out how many numbers are within that range. That's what you should use for your modulus operator. And then what is the base number? Add that to the other side. Maybe this isn't the best example because it's 1,000 and 1,000, but suppose, for instance, I wanted, let's say, 10 to 100, right? How many numbers are in the range 10 to 100? There's 90. And what's the lowest number? 10. all my numbers are in the range from 10 to 100. And you can easily modify this to suit whatever needs you have. This should be very important for your lab this week, in case you have the chance to watch this video before you do it. But that's it for this example, and I think we have one more left. Let's see here. Yes. Okay. Go back to your first program. Good thing I saved it. And overload the hello world's function to print a different greeting if the function is given an integer and 2 initials, which are variables, characters specifically. So overloading here means that we're going to have a second definition for hello worlds. So leaving our random numbers aside, right now we have hello worlds, which takes an integer, but we also want to have a second hello worlds, which is going to take an integer, an initial, I guess first initial, and second initial. Okay, now we'll copy our code because we don't want it to do that much different. Bloop. But we do need to change the parameters. We're going to have a first initial, and copy this into here. So it's going to print hello world my integer times, but we're going to print something different. Instead of hello world, let's print hello first initial dot second initial dot exclamation mark. A slightly different greeting so we can actually use these variables. So all we have to do now is we're going to change hello world to do hello first initial dot second initial dot exclamation mark, new line. Now, when we called hello world from before, I guess I can clear all this code up. Hello worlds, I should say. We went with hello worlds 10, right? Now, I've written a couple of different versions of hello world. Let's see if C++ can figure out which one I'm trying to do. Right now, I'm just trying to print it 10 times, which should give me this one. So even though I've declared hello worlds twice in 2 different versions, since I'm calling it with the one that has only an integer and nothing else, it knows to use this code here. Now, if I want to do the one where it prints out initials, I can do hello worlds, comma, M, comma, S. Oh, sorry, these should be single quotes. S, single quotes. There we go. Something weird's going on here. It's a very good question. Why does it seem to be frozen? It's very odd. Maybe I'll try it again. Okay, I don't know what that was, but and here we go. Now that I'm giving the function different parameters, I'm giving it specifically an integer, character, it's not going to run this function. Even though it could run this function with just the integer that's there, because I gave it more parameters than is expected in this line, it's going to try to match this set of parameters with one of the definitions of the function that's there. And in this case, we have this definition. So it only runs the code that's here, which prints out hello initial dot initial exclamation mark. All right, and now we have successfully overloaded the hello world's function by writing 2 different definitions that do slightly different things with the same function name. And so you'll see this this concept come up quite a bit, especially when you start working with code that has lots and lots of functions, because it's going to, you're really going to want to have functions that have a similar behavior. In this case, they both print greetings, but the way that you do it might change a little bit depending on the parameters that you have available. So in this case, I have initials, so I want to print those initials. This one I don't have initials, so I can't really print anything there. And later on, depending on what parameters you're working with, you may want your function to do slightly different things, which is where overloading comes in. So that's everything for this video, and I'll see you in the next one.